Hello, my name is Eric Hakela, and I lead the business development team at AWS, helping customers to adopt AWS machine learning and AI services to drive new business value from their data. In this session, we're going to talk about how to select the best AI technology for your use case and the general practices that we are seeing our customers follow to build effective data science teams. It's important to think about building a holistic data platform for your business that will allow your organization to answer any business question from data that comes along. This means investing in a flexible data platform that gives your team access to database, analytics, machine learning, and AI tools with the ability to mix and match the best of breed of these tools for each specific data problem. When trying to create new value from data, we recommend that line of business teams work backwards from the business challenges or questions that are worth answering with data. This means starting with new projects by identifying 3 or 4 business questions that would drive a lot of value if they could be answered. Understanding what data is available to potentially inform answers to those questions, and then finally, identifying the right data tool to apply to answer that question with the data that's available is the last step in creating the project plan. Use cases and the data tools available are constantly changing and evolving. Therefore, giving your data analytics, data scientists, data engineers, and other data practitioners access to a flexible data platform to swap in and out the right tool for the job is imperative to drive successful data projects and to eliminate the risk of investing in the wrong tool today for tomorrow's data challenges. By building on a flexible cloud data platform, your data architecture can now evolve and adapt over time to constantly match use cases and the newest tools available. Now let's talk a little bit about the machine learning and AI tools available on AWS. At Amazon, we've been making huge investments in machine learning since 1995. It's important to remember that many of the capabilities customers experience with Amazon are driven by machine learning. For example, our recommendations engine, the paths that optimize robotic picking routes in our fulfillment centers, and our supply chain forecasting and capacity planning are all driven by machine learning algorithms. Amazon's drone initiative, Prime Air, and the computer vision technology in our new retail experience, Amazon Go, are driven by deep learning. We have thousands of engineers at Amazon committed to machine learning and deep learning, and it's a big part of our heritage. Within AWS, we've been focused on bringing that knowledge and capability to our customers. As a result, across every industry, motivated, technically skilled companies are starting to meaningfully use machine learning in their businesses too, and most are choosing AWS as the place to do it. In bringing powerful machine learning capabilities to market, we see the machine learning stack having 3 key layers: frameworks and interfaces for machine learning practitioners, platform services that make it easy for any developer to get started and get deep with machine learning, and then application services that enable developers to plug in pre-built AI functionality into their apps without having to worry about the machine learning models that power these services. The bottom layer is for the expert machine learning practitioners. These are people comfortable building deep learning models, working with deep learning frameworks, and building clusters. They can get extremely deep. For this group, the vast majority of machine learning and deep learning being done on the cloud today are being done on AWS with our GPU instances, which are optimized for machine learning and deep learning. For example, a few months ago, we launched the P3 instance based on NVIDIA Volta V100 GPUs, which provides a huge boost to the speed and efficiency of deep learning and machine learning workloads. When it comes to machine learning frameworks, AWS supports all the major frameworks, including TensorFlow, Caffe2, Apache MXNet, PyTorch, and others, so that you can bring or develop any model you choose. This gives developers the ability to select the framework they want to work with and to select the right tool for the job. Now, when you think about this bottom layer of the stack, unfortunately there aren't that many of these expert practitioners around. More are being educated at universities every year, but it'll be a while before there's plentiful supply of these experts. Therefore, customers want managed machine learning platforms that streamline the time of their experts by eliminating non-value creating infrastructure management and that make it easier and faster for talented developers to learn new machine learning skills to in turn become experts themselves. Machine learning platforms are the middle of our stack and are targeted at removing the complexities of machine learning that can otherwise hold back developer success with machine learning. The best example of this tier of the stack is Amazon SageMaker, which includes modules that can be used together or independently to build, train, and deploy your machine learning models. SageMaker makes it easy to build machine learning models and get them ready for training by providing everything you need to quickly connect to your training data and to select and optimize the best algorithm and framework for your application. Amazon SageMaker includes hosted Jupyter notebooks that make it easy to explore and visualize your training data stored in Amazon S3. You can connect directly to data in S3 or use AWS Glue to move data from Amazon RDS, Amazon DynamoDB, and Amazon Redshift into S3 for analysis in your notebooks. To help you select your algorithm, Amazon SageMaker includes the 10 most common machine learning algorithms, which have been pre-installed and optimized. Amazon SageMaker also comes pre-configured to run TensorFlow and Apache MXNet, two of the most popular open source frameworks, or you have the option of using your own framework. You can begin training your model with a single click in the Amazon SageMaker console. The service manages all of the underlying infrastructure for you, and you can easily scale to train models at petabyte scale. To make the training process even faster and easier, Amazon SageMaker can automatically tune your model to achieve the highest possible accuracy. AWS Deep Lens is the world's first deep learning-enabled video camera for developers. Integrated with Amazon SageMaker and many other AWS services, it allows you to get up and running with deep learning quickly and easily. The purpose of AWS Deep Lens is to help developers learn the basics of deep learning quickly and easily through computer vision projects, tutorials, and real-world hands-on exploration with a physical device. AWS Deep Lens lets you run deep learning models locally on the camera to analyze and take action on what it sees. AWS Deep Lens allows developers of all skill levels to get started with deep learning in less than 10 minutes by providing sample projects with practical, hands-on examples which can start running with a single click. AWS Deep Lens was designed with deep learning in mind, and with over 100 gigaflops of compute power on the device, it can process deep learning predictions on HD video for real time. Models trained in Amazon SageMaker can be sent to AWS Deep Lens with just a few clicks from the AWS Management Console. AWS developers can run any deep learning framework, including TensorFlow and Caffe. AWS Deep Lens comes pre-installed with a high-performance, efficient, optimized inference engine for deep learning using Apache MXNet. At the top layer of the stack, we serve developers and companies who want to add solution-oriented intelligence to their applications through an API call rather than developing and training their own models. In computer vision, we developed Amazon Recognition to allow developers to easily build intelligent video and image analysis into their applications. A good example of how customers are tackling challenges that were previously insurmountable with the AWS services is C-SPAN. C-SPAN is using Amazon Recognition to automate footage tagging, and prior to Recognition, they could only index about half of their footage due to the immense amount of manual processes. But they were able to build a solution using Recognition in 3 weeks and can now scan all their footage to identify and retrieve 99,000 political figures, saving them approximately 9,000 hours a year in labor. In the language space, Amazon Transcribe is an automatic speech recognition service that makes it easy for developers to add speech-to-text capability to their applications. Amazon Translate is a neural machine translation service that delivers fast, high-quality, and affordable language translation. Amazon Polly allows customers to easily turn text into lifelike speech across a large number of voices and languages. Amazon Comprehend is a natural language processing service that uses machine learning to find insights and relationships in text. Amazon Comprehend can identify the language of the text, extract key phrases, places, people, brands, or events, understand how positive or negative the text is, and automatically organize a collection of text files by topic. Finally, Amazon Lex uses the automatic speech recognition and natural language understanding technology that fuels Amazon Alexa to allow developers to quickly build intelligent conversational applications. A common horizontal use case for Amazon Lex that spans most business segments is leveraging chatbots to make customer service organizations more efficient. For example, Liberty Mutual Insurance uses Amazon Lex to provide a chatbot across a broad range of devices to help its employees quickly get answers to questions and complete common tasks. The Amazon AI services can also be used together to create novel solutions. For example, you can use Amazon Kinesis to ingest tweets from across the world in various languages in real time, use Amazon Translate to translate them all into English, pull out sentiment using Amazon Comprehend, populate that sentiment analysis results into an Amazon Redshift data warehouse, and finally visualize the results and the changes in sentiment in a real-time dashboard using Amazon QuickSight. To recap, the bottom two layers of the AWS machine learning stack, machine learning infrastructure and frameworks, and machine learning platforms, are for data scientists that are expert machine learning practitioners, while developers that are not already machine learning experts will find the top two layers, machine learning platforms and AI services, allow them to both rapidly learn new deep learning skills and to easily build AI functionality into their application without being an expert through API calls to pre-trained services rather than reinventing the wheel by developing and training their own models. And in order to do machine learning successfully, you not only need machine learning capabilities, but also the right data store, security, and analytic services to work together in building the holistic data platform that will give your organization the power to answer any questions from data that comes along. Next, my colleague Dan will talk about how customers are harnessing the power of deep learning algorithms to solve business challenges, and also how customers new to machine learning and deep learning are building new data science teams from the ground up.
Hi, my name is Dan Mbanga. I lead business development for machine learning and AI platforms at Amazon Web Services. I've been with AWS for 4.5 years, and as part of the AI and machine learning team, I help our customers bring their AI use cases to production on the AWS stack. Today, we will run through a quick overview of the potential AI brings to digital transformation and how AI platforms enable and accelerate such a transformation. We'll also quickly discuss an organizational model for leaders to build and maintain a data science team. So let's get started. To understand AI better, let's start by reviewing a cycle for AI and how it relates to how humans interact with the real world. As humans, we interact with the real world in many ways. This interaction could be oversimplified by an input processing and output model. We start by perceiving the world around us. Once we perceive information around us, two things can happen. Either we already know what we perceived. For example, I see a friend and I have a knowledge representation of that person in my mind. Or we don't know what we perceive and we learn from it. Learning can happen in multiple ways: by analogy, recognizing patterns or similarities, getting a too hot feedback from touching a cup of coffee. Once learning is done, we end up with a knowledge representation. Once we have a representation, we apply some reasoning on top of it. Reasoning leads us to either plan an execution or execute directly in some cases. We receive perception inputs from things that we see, hear, say, or touch. To represent that information, we use our memories. For learning, we leverage our brains in an adaptive way, both for learning and reasoning. And finally, we execute using what I like calling actuators. These are real-world actions that we take that exhibit intelligence. An example of a flow would be in a two-way communication. I perceive with my ears and eyes. I either know what is said or I learn something new from it. Then I reason on top of the message I just received, and I formulate my response and execute by responding. That's a human way. The way we achieve this in a machine is by perceiving through images, audio stream, different types of sensors, user activity, and other input like clickstream data. To simulate memory, we could use a graph database such as Amazon Neptune or an in-memory database such as Amazon Elasticache to persist knowledge representations. For learning and reasoning on top of the data, we use machine learning and deep learning algorithms. Those algorithms find patterns in newly observed data by learning from previously observed large amounts of similar data. Finally, we plan through business application logics and execute in real world with sensors or devices that simulate intelligence. The goal is to make human-computer interactions as natural as human-human interactions. The success of artificial intelligence relies on the quality and quantity of data, as well as the speed at which the data could be processed. The faster the AI system can respond, the more it sounds like a human. That's why GPUs come in handy. Possibilities are endless with machine learning and deep learning. At Amazon, for example, we've been leveraging deep learning on massive data sets to solve problems in multiple business units. We use deep learning to build recommender systems, for search optimization, for translation, for supply chain optimization, and of course, many computer vision use cases. Our AI services, as a matter of fact, are also built using deep learning. At AWS, we've been focused on bringing that knowledge and capability to our customers. We approach this by splitting our machine learning stack into 3 key layers: frameworks and interfaces for machine learning practitioners, platform and services that make it easy for any developer to get started and get deep with machine learning, and application services that enable developers to plug in a pre-built AI functionality into their applications without having to worry about machine learning models that power these services. We'll focus on the bottom 2 layers. The bottom layer is for expert machine learning practitioners. These are the people comfortable with building deep learning models, working with deep learning frameworks, building clusters, and more. They can get extremely deep. For this group, the vast majority of machine learning and deep learning today is being done on the AWS cloud with our GPU instances, which are optimized for machine learning and deep learning. In October 2017, we launched the NVIDIA Volta GPU-powered P3 instances, which is 14 times faster than the Kepler P2 instance. P3 provides a huge boost to the speed and efficiency of deep learning and machine learning workloads. It's still early day in deep learning. Many frameworks such as MXNet, TensorFlow, Caffe, PyTorch exist to facilitate the implementation of deep neural networks. At AWS, we provide a deep learning machine image designed to enable just that. It's a pre-configured machine image with the most popular deep learning frameworks, as well as the data science tools such as scikit-learn, pandas, numpy, and GPU acceleration libraries such as NVIDIA's CUDA libraries and Intel's math kernel libraries. The idea here is to enable AI research and development by taking away the heavy lifting, but there's more we could do, and we did just that. Mostly because, unfortunately, there aren't many of these expert practitioners around. More are being educated by universities every year, but it'll be a while before there is plentiful supply of these experts. That's why at the middle of the stack, we have machine learning platforms, which abstract more heavy lifting and makes it easy for non-expert developers and DevOps guys and expert data scientists as well to have a machine learning purpose-built environment to build, train, and deploy machine learning models. Amazon SageMaker is an end-to-end platform that removes the complexity that holds back developers' success in machine learning. Amazon SageMaker includes modules that can be used together or independently to build, train, and deploy your machine learning models. SageMaker makes it easy to build machine learning models and get them ready for training by providing everything you need to quickly connect to your training data and to select and optimize the best algorithm and framework for your application. Amazon SageMaker includes hosted Jupyter notebooks that make it easy to explore and visualize your training data stored in Amazon S3. You can connect directly to your data in S3 or use AWS Glue to move data from Amazon RDS, Amazon DynamoDB, and Amazon Redshift into S3 for analysis in your notebook. To help you select your algorithm, Amazon SageMaker includes the 11 most common machine learning algorithms which have been pre-installed and optimized to deliver up to 10 times the performance you'll find running these algorithms anywhere else. Amazon SageMaker also comes pre-configured with TensorFlow and Apache MXNet, two of the most popular open source deep learning frameworks. It doesn't end there. You also have the option to use your own framework in Amazon SageMaker. You can begin training your model with a single click on Amazon SageMaker using the Amazon SageMaker console. The service manages all of the underlying infrastructure for you, and you can easily scale to train models on petabytes of data. To make the training process even faster and easier, Amazon SageMaker has in preview a hyperparameter optimization module that can automatically tune your model to achieve the highest possible accuracy in the shortest amount of time. Once your model is trained and tuned, SageMaker makes it easy to deploy in production so that you can generate predictions on new data. Amazon SageMaker deploys your model on an autoscaling cluster of Amazon EC2 instances to deliver both high performance and high availability. It also includes built-in A/B testing capabilities to help you test your model and experiment with different versions to achieve the best results. We designed Amazon SageMaker in 3 modules: build, train, and deploy, that can be used together or independently as part of any existing machine learning workflow you might have already. SageMaker is a powerful platform that materially reduces the time it takes to run machine learning workloads in production. How do you build a team of professionals to solve your business problems with machine learning on SageMaker? We will conclude with some quick advices on how to build a data science team and organize for success. From a people or profiles perspective, machine learning is inherently interdisciplinary. Organizations tend to think that one needs an advanced degree in math or science to fit the role. I'd argue that it's not enough. If you think about it, machine learning teams work with sensors data and also embed results of machine learning in real-life applications, scalable applications. Core mathematicians will struggle with that. I recommend looking at these 4 profiles: a physical scientist, an analyst, a mathematician or a computer scientist, and an architect to complete your machine learning team setup. Let's look at some specifics. The physical scientists are used to working with data to solve real-world problems. Those are physicists or bioinformatics folks that can natively model a real-life problem into a useful, clean, and pre-processed data set. They will also know how to present the results within your organization. Your analysts will work with your physical scientists in order to formulate the right questions or identify the business questions that need some machine learning investigation. The computer scientists and/or mathematicians understand the details of a machine learning algorithms. They will be the right person to select the best algorithm or hyperparameter range to optimize for. Every serious machine learning project has an initial research and exploratory aspect. The computer scientists will help with the fast convergence to the best and most accurate model. Finally, your architects or integrators can ensure that everything lives within the right application stack and requirements. They can put everything together.